Alrighty, in today's video, we're going to be talking about 6.4, which is the fundamental theorem of algebra. All right, so basically now that I pretty much have taught you how to solve any type of polynomial function, we're going to use that to kind of help us graph them. Now, granted, I do allow calculators. I do recommend that you do learn the process because your next class may not allow calculators, and it might, I don't know. But eventually you need to be able to do this by hand as well. But so use the calculator more to check to make sure you're understanding how you're graphing these functions. All right, so in the fundamental theorem of algebra, it basically just states if P is a polynomial, um, if P is a polynomial, sorry, trying to make this sound better than what's in the book. So if P is a polynomial, then there is at least one solution, real or imaginary. All right, so I'm not saying that it's always going to cross the x-axis to have a solution, but it will have an imaginary answer as well. So that's basically what the fundamental theorem is. As long as it's a polynomial of like a linear function as the smallest, all the way down to an infinite one, right? It goes many times. That's pretty much what it is. And so that's the fundamental theorem of algebra. Now, off that, they come up with the linear factors theorem. Which basically just states if a polynomial can be written like this, basically, if it's written in standard form, this is standard form, then it can also be written in factor form. So the same leading coefficient, and then just simply whatever the factors may be, even if it's an imaginary factor. So basically, that is what the factor theorem states. If it is written in standard form, it can be rewritten in factor form and vice versa. Now, other ways to interpret this as well is that a nth degree polynomial will have n x-intercepts. Well, I'm going to rephrase that. Xn solutions, because again, it can be imaginary or real, and at most, so this is a big one. At most, n minus one turning points, which are basically where it changes directions. Now, it doesn't have to have n minus one, but it'll only have most as n minus one because if it goes through all these different n's, it can only change direction one less than that amount. And that will kind of give us an idea of what kind of graph it'll be. So that kind of gets into this idea of multiplicity. So a lot of my students struggle with this concept of multiplicity, but basically all it means is the amount of times you got an answer. So I could have, I don't know, let's say a fourth degree, and I see that I have an answer of 0 and 1. And I'm like, well, that's only two solutions. Our professor said there's supposed to be four. Well, what happens is that 0 and that 1 can have happened multiple times. So maybe I had 0 and 1 both twice. So I still got four answers. They just repeated. And so the multiplicity of that would just be that the multiplicity of zeros needs to equal n. So however many answers you have. But the multiplicity itself just could be that, hey, I got 0 twice and I got 1 twice. But in total, I still got four answers. All right, so that's basically what multiplicity basically comes out to. Now, the reason we talk about multiplicity is because if multiplicity is even, it'll touch the graph, or a better way, maybe bounce off the graph. So it kind of look like this. You'll have a x-intercept, but it'll bounce and come back up. That would mean that this right here had a even multiplicity. So that's 2, 4, 6, 8, 10 times. A odd multiplicity goes through the graph. So that means I might have something that looks like this, where both of these are going to be odd multiplicities because it goes through the graph. So they could have happened 1, 3, 5, 7 times. So that's why we talk about multiplicity, because they can kind of help us see how the graph would look. The next thing is the conjugate rule theorem. It's a lot of theorems in this one. So the conjugate roots theorem basically just states if a minus or a plus bi is a 0, then a minus bi is a 0. So if I give you a complex number as a hey, solve this given that this complex number is a 0, then you automatically know that its conjugate is also a 0, which will help us lower that polynomial function down to a point where maybe we can factor it or quadratic. So for instance, if it was an x to the fourth power and I give you a complex number, I technically just gave you two zeros, and you can work the x to the fourth polynomial down to an x squared. And then we can factor, solve, cancel, whatever it is that we need to do to solve the rest of it. So that's what the purpose of this theorem, to kind of help your life a little bit out. All right, so here we go. So I'm going to kind of work out some problems. We're going to be on page 419, and we're basically going to kind of solve it and graph it all in the same process. So I'm going to look at number 4 first. This says g of x equals x plus 2 and x minus 1 to the third power. So what this tells me is that this is a fourth degree polynomial. Okay, so from that, I have a fourth degree polynomial, and I have the zeros are going to be the opposite of these signs. So it's going to be -2 and 1. Since this has a 1 and a 3, that means it's odd. So that means that at -2, it's going to go through the graph, and at 1, it's going to go through the graph. And since it's a fourth degree with a leading coefficient, so let's do this. So it's an even and positive using our, how our, oh, what's that word? Oh, I got it on the tip of my tongue. It's the leading term tells you the end behavior of the graph. It tells me, so if it's an even positive, I know it's going to start up and start up. And since I know it goes through the graph, then I know the graph is going to do something like this. All right. Now here's the harder part is determining where exactly it crosses the y-intercept. And that's kind of where you have to plug in. So one of your homework questions is going to be like, hey, what's the y-intercept of this guy? And so to do that, you just have to plug in 0 like we did before. This would be like 2 times -1 to the third power, so that's -2. So that'd be -2 right there. So now my graph looks a little bit maybe better in a sense that, all right, I know I'm going here, and then at some point I come back up this way and do something like that. All right, and then so that's about as far as we can go right now. And then you can use your calculator to kind of go, all right, is this about right? And then go from there. Right, so that's kind of using your in behavior, your zeros, your multiplicities, finding your y-intercepts, your x-intercepts, your zeros. And that's about as far as we can go on that type of problem. And again, you just use your calculator to kind of help make sure you're on the right path. All right, so on number 7, I want to see your homework is going to help say, hey, identify your zeros and your y-intercepts, and then your end behavior. And then I think the graph kind of does the rest of it for you. But if you need more questions on how to use the technology, by all means, I don't mind going through that. All right, let's go through number 7. So 7 is f of x equals x minus 4, x plus 2 squared, and x minus 3 cubed. So again, I have a 1, 3, 6. I have a 6th degree polynomial. So that's going to be even and positive. So I'm looking at a graph. I know my end behavior does something like this. Ooh, that's one's bad. Try more like this. And then I know my zeros are 4, -2, and 3. So I go 1, 2, there's a 0 there. 1, 2, 3 is a 0 there, and 4. Now, what this also tells me is at at 4, it's going to go through the graph. At 2, so kind of do this. So I'm going to start here, and I'm going to go to the first one, which was -2. -2 has a even multiplicity, so it's going to bounce off, and then from there, I need to turn back eventually, back to 3. 3 being odd tells me it's going to go through the graph. And then 4 being odd tells me I'm going to go back through the graph. So I get a function that roughly looks something like this. Again, the only other thing it's going to tell you to do is find the y-intercepts. That's going to be 0 minus 4, 0 plus 2 squared, and 0 minus 3. So that's -4, 2 squared, and -3. So that's going to be 12 times 4, which is 48. So it's going to be somewhere way up there. We'll pretend this is 48. All right, so that's kind of really how to work those type of problems out. All right, and again, you can use your graphing calculator to get maybe a better estimate of where things go. That's pretty much all I think I saw at your homework asked. But let's look at number 8, just give you another example. So g of x is equal to x plus 3 and x minus 1. Again, I can see that this is a 6th degree polynomial. So it's even and positive. So it's going to be somewhere up here and somewhere up here. And then I see that my zeros are -3 and 1. So 1, 2, 3, and 1. I can see at -3, it's odd. So both of them are odd. So it's going to go through it at some point, come back through it just like that. And then I'm going to look for a y-intercept as well. So that's going to be 0 plus 3, 0 minus 1 to the 5th. So that's going to be 3 times -1 to the 5th power. So that's going to be -3. So we'll pretend that's -3. And it might do some loop-de-loops, but your calculator will help you kind of identify that a little bit better. All righty. So let's look at a different type of way of present it. Let's look at number 10. 10 says use all available methods to factor each of the following polynomials completely, and then we're going to sketch the graph. So this time, you're not so easily given your factors. So in this concept, we have more of a solving thing of what we did in the previous section. I don't see anything that they have in common, so I'm going to use my new skills of finding my potential zeros. So that's going to be 1 and 5 and 1 and 2. So that's going to be plus or minus 1, 5, 1/2, and 5/2. And then from there, I'm going to try some zeros. All right, I'm going to try -1. So that's going to give me x cubed and 2, x squared -1, x and -8, constant -5. -1 doesn't work, but I'm thinking 1 will for sure. -2, -3, 3, -5, and 5. Good. So that's what I was thinking was going to happen. So I'll give you 2x squared minus 3x minus 5. And then if I try to factor this, I need to multiply to my a times c, which is -10, add to my -3, 2 and 5, and negative. So that give me x plus 2, x minus 5. Divide that by 2. So that's 1, and I can't simplify that. So it does want me to write it out in factored form. So I do need to finish this out. So this would be x plus 1, and then 2x minus 5 plus your 0. So we change the sign, and that's going to be x plus 1 again. But instead of repeating it, I'm going to write x plus 1 squared, and then 2x minus 5. And there you go. That's pretty much what you have to do there. And then from that, we're able to sketch the graph. So I'll know I have a 0 at -1. I know I have another 0 at 5/2. So that's 1, 2, 3. So about right there. And I know that this right here would be an odd positive. So it's going to do something like this. And I know at -1, it will bounce off because it's an even multiplicity. And at some point come back through a odd multiplicity, because this right here would mean that it's even multiplicity, so that bounces. So then we got something like that. I think this is the big gist of it, is basically rewriting the polynomial function in factor form and then using that to help you graph. Alrighty, let's see. So that was number 10, right? All right, so let's look at number 12. 12 is f of x equals -x cubed plus 6x squared minus 12x plus 8. Again, I'm not seeing any good factors here. Therefore, potential zeros. Factors of 8 is 1, 2, 4, 8 over 1. So that's plus or minus 1, 2, 4, 8. So now I'm going to try a potential 0. And let's try 2. So it's going to be x cubed is -1, x squared is 6, x is -12, c is 8, -2, 4, 8, -4, -8. So this gives me -x squared plus 4x minus 4 equals 0. So then I'm going to multiply it all by negative because I don't like the negative. So that's going to be positive x squared minus 4x plus 4 equals 0. Two things that multiply to 4 but add up to -4 is x and -2 and x minus 2. Bring down the other factor, which was x minus 2, because you have to change the sign. So really, this is x minus 2 cubed. And I don't think we can go any further than that one. Due to other than the fact that that negative is here. So when I'm solving it, I can apply this, but since I did this step, when I'm trying to rewrite the polynomial function, I need to bring that negative back in. So it's really going to be negative x minus 2 cubed. So make sure we add that negative back in there. And then graphing it, now that it's a odd negative, I know the result looks something like this. And I got a 0 at 2, and it goes through the graph. Maybe something like this. Maybe it goes a little different direction. I just know it doesn't go through the x-axis, no more than that. All right, let's try number 13. 13 is h of x equals x to the fourth minus x cubed minus 5x squared plus 3x plus 6. So potential zeros. 1, 2, 3, 6 over 1. So that's plus or minus 1, 2, 3, 6. So on this one, let's try -1. So x to the fourth is 1, x cubed is -1, x squared is -5, x is 3, and my constant is 6. So it's -1, -2, 2, -3, 3, 6, -6 is 0. So this would be x cubed, -2x squared minus 3x plus 6. And we'll try 2 next. So this will be 1, -2, -3, and 6. 2, 0, 0, -3, -6. So this gives me x squared minus 3 equals 0. Do we want to? Well, they want us to do that. So I'm going to go ahead and solve it and then just use that as my C1s. So that'd be 3. So then that right there would mean that x equals plus or minus the square root of 3. So when I rewrite this, I want to write it as x plus 1, x minus 2. So those are my answers right there. And then using those factors, have x plus the square root of 3 and x minus the square root of 3. And then to graph that, I know I have a result at -1. 2 square root of 3 is between what? 1 and 4. So we're going to say there's one about right here, and I'm going to say there's one about right here. And then this is a even positive, so I know it's going to do something like this. And they're odd multiplicity, so it's going to do roughly something around that ballpark. Maybe not as pretty, maybe a little bit higher, who knows. All right, let's do another one. Number 14 is h of x equals x to the fifth minus 11x to the fourth plus 46x cubed minus 90x squared plus 81x minus 27. So my potential zeros here are 1, 3, 4, 5, 6, 7, 9, and 27 over 1. So that's going to be plus or minus 1, 3, 9, 27. So let's see. So let's try. We'll try +1 first. So that'd be x to the fifth. That'd give me 1. X to the fourth is -11. X cubed is 46. X squared is -90. X is 81. And my constant's -27. So -10, 36. That's going to be 90 minus 36 is 50, -54. 81 minus 54 is 27. Okay, cool. And then from there, let's try 3. So that would be 1, negative 10. Because right now it's x to the fourth. 36, negative 54, and 27. So that 15, 45, negative 9, negative 27. And that gives you 0. So that's fourth. Now we're at a cube. Let's see. I don't think 9 will work. I'll multiply those too hard. Let's see. Negative 1 won't work. Negative 3. Now here's a technique that you could do. If there's another 0, like a multiple repetitiveness, we can try those numbers again. If not, it won't work out. So I'm going to try 1, and then I'm going to do 1, negative 7, 15, and negative 9. So let's try this technique. Yep, there it is. All right, cool. So now I'm down to x squared minus 6x plus 9, which is x minus 3. So I could have used 3 as well, multiple times, it looks like. All right, so I got the answer 1, 3, and 1. So that means that this will be x minus 1 squared and x minus 3 cubed. So what will happen is if it does have a multiplicity, it'll work again. However, if it doesn't have a multiplicity, when you try that same number again, it won't work. So then that will tell you, okay, well, that doesn't work. And I only did that because I just know 9 and 27 was not going to be good. And I was like looking at the negatives, and it just didn't seem like that was going to work out either. So there is your factored form. So then I can come over here and go, all right, this is odd and it's positive. So it's going to start something like this. And then I got 1 at 1 and 3. And 1's even. So I'm going to come over here and I'm going to bounce. And 3's odd. So then I go something roughly like that. And that's about it. All right. So let's look at one where all you have to do is just solve them, which I prefer just to solve. I hate graphing. But you can use your graphing calculator to help you out as well. That I do not mind. X to the fourth plus 15 on number 18 equals 2x cubed plus 8x squared minus 10x. Just like we did in the previous section, I need to set this equal to 0. So I'm going to subtract 2x cubed, subtract 8 squared, and add 10x all over here. So I get x to the fourth minus 2x cubed minus 8x squared plus 10x plus 15 equals 0. Now it's time for me to solve. Again, I don't see anything in common. So my potential zeros here are 1, 3, 5, and 15. I'm going to write plus or minus because I can see that I'm just dividing that by 1. So a potential 0 here. Let's try negative 1. So I'm going to drop down my 1. So that's negative 1, negative 3, 3, negative 5, 5, 15, negative 15, 0. That only gets me down to a cube. So let me try positive 3 this time. So that'd be 1, negative 3, negative 5, 15. That's 1, 3, 0, 0, negative 5, negative 15, 0. So then this right here ends up being x squared, because that's a cube, then an x squared, minus 5 equals 0. So that gives you x equals plus or minus the square root of 5, because I'd add 5 and take the square root of it. So therefore, my answers are negative 1, 3, and plus or minus the square root of 5. All right, the next type of problem you'll see is like number 28, where it tells you to solve, but it gives you one of the zeros, which does make your life a little bit easier. X to the fourth minus 2x cubed plus 14x squared minus 8x plus 40. And it tells you that 2i is a 0. So I'm going to plug in 2i. That's 1. That's negative 2. That's 14. That's negative 8. Constant's 40. Drop down the 1. That's 2i. Can't actually combine that, so it's negative 2 plus 2i. And then when I distribute this, this will give me negative 4i. And then this will give me 2i squared, which will be negative 2. And then from there, I then add that, and that would give me 12 minus 4i. So then 2i, that would give me 24i. And then that would give me negative 8i squared, which is now going to be positive. And then that would cancel, giving me 24i squared. Oh, wow, I cannot do math. Hold on. 2 times I is not 24, it's 8. So then that'll give me 8i. Hold on. Okay, 1, 2, negative 2, negative 4, 4i squared is negative 4. Goodness. Negative 4, which will then give you 10. And then from there, we just multiply correctly. So that'd be 2i times 10 is 20i. And then that would be negative 8i squared, which is just positive 8. That cancels 20i. That would then give me 40i squared, which is just negative 40, which would be 0. If it tells you it's a 0, it has to work, right? So if 2i is it, using the conjugate theorem, now I know that negative 2i is a 0. So I'm going to use the same things here. So that gives me negative 2i. This is negative 2. That gives me positive 4i. That gives me 10. That gives me negative 20i, which gives me 0. Now I have x squared minus 2x plus 10, which then is x, not 5 and 2 I thought it was going to be. I don't think that can be factored. So then I need to go use the quadratic formula. So x equals negative negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 10 divided by 2 times 1. That gives you 2 plus or minus 4 minus 40 over 2. And then that would give me 2 plus or minus negative 36. That would be 6i over 2, which will then be 1 plus 3i. So you have 4 imaginary answers. You got plus or minus 2i and 1 plus or minus 3i. Those are fun. So there's that, and it says use all available methods, in particular the conjugate root theorem, if applicable, to factor each of the following polynomials completely. Oh, we gotta write these as factors. So then from there, this is going to be x minus 2i, x plus 2i. Distribute the negative, you would get x minus 1 plus 3i and x minus 1 minus 3i. And that would be what the factored form looks like. I think that's how they want it. Let's see, or do they not want that distributed? Nope, they do. Yeah, so that's good. Sometimes they want to keep that in parentheses, but that's good. So that would be what the actual answer was looking for. The other thing you have to be able to do on this is be able to construct a polynomial function given the information. So looking at number 37, you're told it's a third degree, only real coefficients, negative 1 is a 0, so that means x plus 1 is a 0. 5 plus I, so that'd be negative 5 minus I is a 0. And if that's a 0, then so is x minus 5 plus I. So the conjugate is our 2 zeros, and a y-intercept is negative 52. So how far they want us to write this out? Okay, we have to write it all the way out. All right, so from here, we just need to FOIL this, and this is a process. I'm going to do this one first because I know the i's would cancel. In reality, it's pretty much one's a positive, one's a negative. If I factor out a negative, that'd give me negative 5 plus yeah, it's a stretch. So I'm going to distribute this out. So I'm going to drop down my x plus 1. So all I did was turn the zeros into factors. And then this was the conjugate of this one. So if this is it, this one has to be it as well. So that gives you x squared minus 5x plus ix. And then negative 5x plus 25 minus 5i. And then negative ix positive 5i and negative I squared. So all I did was distribute. And then from there, get my like terms. I get x squared. Ix's will cancel. 5i's will cancel. And this right here will turn into a plus 1. So therefore, I get negative 10x plus 26. And then now I can distribute this one right here. So this will give you x cubed minus 10x squared plus 26x plus x squared minus 10x plus 26. So that gives me x cubed plus minus 9x squared plus 16x plus 26. But the issue is, it did say that the y-intercept's negative 52. So then one last step, I got to multiply this by negative 2 to make that happen. So this is negative 2x cubed plus 18x squared minus 32x minus 52. So that would be the end result. All right, let's try another one. Number 43. I did give the, yeah. So 43 is a third degree. Coefficients are, or zeros are negative 4, so that's positive 4. 3 plus I, so it's x minus 3 minus I, and x minus 3 plus I. And then the y-intercept's negative 40. So we'll do the process again. So this would be, again, x squared negative 3x plus ix minus 3x plus 9 minus 3i minus ix plus 3i minus I squared. So this is going to be x squared. The ix's will cancel. The 3i's would cancel. This becomes plus 1. So that's going to give me negative 6x plus 10. Fold again. So I get x cubed minus 6x squared plus 10x. And then 4x squared minus 24x plus 40. So then I get x cubed minus 2x squared minus 14x plus 40. And the y-intercept's supposed to be negative 40. So all I got to do is subtract 1. So I get negative x cubed, or multiply by negative 1, sorry. So I get negative x cubed plus 2x squared plus 14x minus 40. So there's your answer there. And of course, this wouldn't be a college algebra class if there wasn't at least one word problem. So 47, you have an open top box is to be constructed from a 10-inch by 18-inch sheet of 10 by cutting out the squares from each corner as shown in the folding up of the sides. Let V of x denote the volume of the resulting box. We've actually done a problem like this in a previous chapter, but now we're going to kind of focus on how to write the equation. So we're going to write V of x as a product of linear factors. So remember, I guess I'll do the work here. From the previous section, these are all x's. And if this is 10, then the inside would be 10 minus 2x. And this is 18. This would be 18 minus 2x. So then to find the volume, it would simply just be x times 18 minus 2x times 10 minus 2x. So that's all you would have to do. Because you're writing it as the product of factors. And then B said for which value of x is V of x equal to 0. So then you just set each one of those equal to 0. So x equals 0 will be 1. 18 minus 2x equals 0, and 10 minus 2x would equal 0. So then you subtract 18, divided by negative 2, you get 9. Subtract 10, divided by negative 2, you get 5. And it says for which answers in part B are physically possible. Let's see. Let's see. So if you let x be 0, this could just be 18 and 10. So I think that would be possible. If you let it be 9, it would work here, but it wouldn't be possible here. Because if this is 9 inches and 9 inches, that would be too big. So 9 would not work. 5, we could make it 5, or this would be 8, and this would just, it would be cut completely. So these are possible outcomes, but not outcomes you really want to go with. So I think in the previous section, what we did is we found the maximum volume of it. But here we're just looking at potential possible zeros and if they're even realistically possible is what you're looking at here. All right, so that was a lot. But as always, if you need any more help, just keep emailing me and I'll keep helping you through there. Other than that, that is all I got for this video. I'll see you in the next one. Bye for now.